Okay, so the cost of using a new motorway was initially free and 4,500 vehicles used it each day. A toll was introduced that gradually increased. Let the toll charge be C in dollars and the number of vehicles using the toll be N. So an exponential model in the form of y equals b to the negative x times a describes this situation. So what is the model if x and y are replaced with c and n? So what we're going to be modeling here, which letters will we be replacing? Well, if we just take it respectively, then we have n equals b to the negative c times a. So the bigger c gets, the more it costs. Then this, which is 1 over b to the power of c, becomes smaller. So essentially what we're seeing is fewer people use the toll road when the toll increases. Determine the value of A in the model by using C equals 0. So when the cost is 0, N is 4,500. And if C is 0, then B to the 0, that just becomes 1 times A. So that means A must be 4,500. Determine the value of B if there were 3,000 vehicles using the toll for a charge of $1. Okay, let me change up the color here. So we have 3,000 is equal to b to the negative 1 times 4,500. If we divide both sides by 4,500, this becomes 2/3. So 1 over b is equal to 2/3. In other words, b is 1.5, or 3 over 2. Determine an exponential model using c and n to describe this situation. They've made this c capital all of a sudden, but I don't think that that's intentional. I think it's the same c. So what they're looking for is n equals 1.5 to the negative c times 4,500. So everything we've done in part A is just to derive this equation. They didn't have to break it down into parts I, and IV. That was not necessary, but it helps us work through methodically. Okay, construct a table of values using C dollars to represent the value of the toll and N for the number of vehicles using the motorway each day. Okay, so if we say C and then let's put N there. So let's do whole numbers, I think. How do I, that's just going to add rows. Let me try again. 1, 2, 3, 4, 5. Cool, yeah, they just asked about up to 3, so that should be fine. Oh, and I should have started with 0. Well, we know what 0 is. We know that 1 is 3,000. So let's see, if C is 2, I'm just grabbing my calculator here. We've got 1.5 to the power of negative 2 times 4,500. So that's 2,000. Let me change that power to be negative 3. And that's rounded to a whole number. It's this. And then if I change that power to a negative 4, then rounded to a whole number, it's this. And if I change it to be a negative 5, then rounded to a whole number, it is this. Okay. Plot the table of values on a number plane. All right, so this is a question that is appropriate for Desmos. Let me try to resize this guy. Come on. Okay, so We have the point 0, 4,500. We have the point 1, 3,000. We have the point 2, 2,000. That's correct, yep. And then it's 3, 1, triple 3. And then it's 4, 8, 8, 9. Yes, and 5, 5, 9, 3. Okay, so we can't see anything, so we have to change our Desmos settings. Let's see, so the x-axis can go from, let's go from -1 up to 6 so that we can see each endpoint, and the y-axis can go from 0 up to 5,000. Okay, so my head's in the way. Here are our plotted points. I'm going to resize this window again. Okay, so there are our plotted points. Let me screenshot this. Now, how many vehicles use the toll if the charge was $3? Well, the answer we already have is 1,333. If there's that many vehicles each paying $3, then the income received will be 3,999. A higher toll always means a higher daily income. Do you agree with this statement? Okay, I don't. Let's see if we can put some numbers on this. So here, if we have 3,000 people paying $1, that's going to be $3,000 in income. If we increase that total to $2,000, the income does go up. It goes up to $4,000. As we just found, when we get to $3 each, it goes down a little bit. It becomes 3,999. It's basically the same. Then what is 4 times 889? 3,556. And then 5 times 593 is 2,965. So because this graph is not a straight line, we don't have a clear trade-off where a an increase in the cost leads to a linear decrease in the number of people using it. And what we're actually finding is that there's a sweet spot where you maximize income, but if you increase beyond that sweet spot, the decrease in the number of people using the toll road actually reduces the amount, like the total revenue collected. So that's my explanation of the answer. I'm not going to bother to write it out. You can try and put my words into your own, put my ideas into your own words. Okay, I think that's everything. Let me know if that made sense for you.